I'm Aygün Varol. I'm a doctor researcher here at Tampere University. I'm with Augmentative Technology Group. This is the outline of my talk. First, I will start with an introduction of smart spaces, and we will continue with the role of AI and their applications. Then we will delve into challenges of utilizing AI. After that, the core of this talk, we will talk about AI agents in smart spaces, then discuss about what can go wrong if we deploy AI agents in smart spaces. And finally, I will present my own prototype, local running AI agent to you. Here's a picture that comes to our minds when we think about smart spaces. It consists devices such as smart home appliances, enablers, sensors, cameras, and wireless network. And we have wireless computing technologies here, such as device, edge, and cloud computing. Smart spaces are indoor environments equipped with IoT devices, such as sensors, actuators, or machines. They interpret this collected sensory data to provide applications to users, such as energy management, home automation, and security. IoT is backbone of these systems. It enables objects to connect over internet. Okay, they have four key components, namely sensor technologies is used for collecting environmental data. Data communication is for transmitting this data over devices. Network management is engineering of allocating sensor devices of the environment and selecting appropriate wireless technologies. Data collection and processing is for processing data for provide some user-centric solutions in the environment. First, I will start with sensor technologies. It is fundamental technology for smart spaces. We have different kinds of sensor devices here. I grouped them based on their selected applications. First set of sensors are environmental sensors and infrared sensors and cameras. Environmental sensors measure air quality, CO2, humidity, pressure, temperature, and infrared sensors and cameras are utilized mostly for human recognition in smart spaces. To send the collected data of sensor devices, we utilize data communication. These sensor devices send their information through wired or wireless communication technologies. However, in smart spaces, typically wireless communication technologies are used. Here I listed most common wireless technologies that are deployed in smart spaces, namely RFID, NFC, Bluetooth, Zigbee, Wi-Fi, extended GSM IoT, Node B IoT, and long-term evolution for machines. I classified them based on their ranges. We can see even Wi-Fi supports up to 1 kilometer, and there are solutions more than that. These selections are based on their ranges and their maximum of support data rate. For example, if we utilize cameras, then I recommend to use Wi-Fi technology because it supports high data rates. However, when we utilize Wi-Fi in our systems, the power consumption would be high. Another key component is network management. Here we are interested with sensor calibration and their energy usage because IoT devices most of the time battery operated. So in order to long operation, we need to manage energy usage for these devices. And lastly, data collection and processing. Sensors generate big data with different volumes, varieties, and velocities. What I mean by that, the velocities is we think of speed of their measurement time. For example, a environmental sensor may produce information interval of 1 millisecond, for example, and they produce different data types, varieties. Environmental sensors could produce CSV file or XML file. and cameras can produce audio or video streams, different types of data, and we have to, of course, process all of them together. And in smart spaces, applications require instant response. When you ask the home environment, please open the light, you don't want to wait 2 minutes just to process that natural language and open the light. You have to be rapid. So we use cloud computing, edge computing technologies to provide these real-time applications. Cloud computing offers substantial computing power. However, there is a risk of privacy because when you send local data out of the home to the cloud, there is always risk of privacy because some intruder can come and steal your data. It could be middleman. There is a risk of privacy here, and sending and receiving data takes time. There might be delays in your system. On the other hand, edge computing provides lower computational capabilities since it runs on edge devices on your local area, but it provides improved privacy and reduced latency. We don't send data to cloud, we process it locally. We don't want to select only one of them. We can utilize both of them, and we can create an algorithm to select which one would be better in some scenarios for our system. Example applications in current smart spaces are energy management, security, environmental monitoring, home automation and control. Here are real examples of these technologies. Amazon, Alexa and Echo devices, Philips Hue smart lighting devices. Also, Google provides some smart home materials for, again, for intruder alert and home automation. Current systems typically rely on rule-based system and manual configuration. They don't learn from you, they don't adapt to user behaviors, and they lack capacity of interpreting the data and generate meaningful actions for the future. So, overcome these limitations, we need AI-driven solutions. So far, we only interested in smart spaces and how to create them, core components of them. Now we will move on to AI, role of AI in these systems. Role of artificial intelligence in smart spaces started with machine learning, and such as multiple layer perceptrons, etc., and to advanced models like deep learning, transformer network, and large language models. These AI models have different solutions for smart spaces. For example, machine learning has low parameter but low accuracy. Large language models have huge parameters and provide good applications for the environment. However, there is a power consumption issues then. We have to select which one would be the optimal one for our scenario. Traditional machine learning methods, the system typically works like this. We collect data, someone pre-processes the data, and then we get feature extraction from it. Then all processed data trained the model, and trained model works on the environment. It's a huge process and requires some expertise on programming. Examples of machine learning, traditional machine learning models are multiple layer perceptron, random forest, support vector machines, k-nearest neighbors. Here we see an application in smart spaces is activity classification. Researchers put devices on users' right leg and right arm to collect data to classify activities. Deep learning models are more advanced since they have automate feature extractions. So they removed one part of the whole huge process, and they are convolutional neural networks, recurrent neural networks, autoencoders, long short-term memory, the gated recurrent unit. Here we see more advanced application because researchers take one frame of infrared sensor, and deep learning model enables people counting just by that image. This is a clever way to use deep learning model because you cannot deploy cameras in indoor environments because of the privacy issue. You can get away with using infrared sensors and deep learning models. Okay, transformer-based networks. This is a huge revolution for AI and also smart space applications. They are introduced in 2017. Attention is all you need paper. They have a specific feature called self-attention mechanism. It allows transformer networks to capture important parts of the data. We have lots of sensors on the environment and they produce all the time lots of data, but most of the time they are useless. We have to interpret them. So transformer networks come in handy in this type of scenarios. They can detect anomalies or important parts of the data. We see applications started to change here. Now from activity classification to action anticipation. Now they started to predict the future. In this study, researchers utilized transformer networks to anticipate next frame. Here, user doing some meal in the kitchen and it understands that activity and anticipate further actions to provide arrange environments for future actions. Transformer-based networks also employed for activity recognition and fall detection. However, we see here, since it does activity recognition, but it doesn't require some additional device. Let's recall traditional machine learning. Researchers had to use some IoT device to collect data, but we don't need to put any of the sensor of the environment. Researchers do this activity recognition just by using Wi-Fi signal strength. Just by your Wi-Fi network, they can detect what you're doing with activity recognition. Similar work is fall detection. Researchers put RFID antenna to the environment and without any additional device for the human. And it can detect fall detection. This work is particularly important for elderlies who are living alone. In emergency scenarios, this system could come in handy. And these additional sensorless applications called non-intrusive methods in the literature. Okay, large language models are also a big step for smart spaces because it allows us to speak with the environment. Large language models are deep learning models with billions of parameters. So they have some prior knowledge of how world works. They also leverage self-attention mechanism just like transformer networks and produce human-like language. Large language models access external data through retrieval augmented generation technique. These models are big and even utilizing them requires so much computational power. We cannot train them, so we use this RAG technology to give environmental data to large language models so that it somehow understands the current conditions of the environment and outputs better responses and contextually aware responses. This is the prominent example of LLMs, OpenAI's generative pre-trained transformer, as we know it, ChatGPT. It is used for converting natural language into actions. This is a good step up for smart spaces because previously it was manual configuration. In this work, we say set up for a party and the GPT-3 produced JSON output setting lights to different colors. So without any pre-programming, system can do that and understand your intent from what you're saying. Previously, engineers and designers had to sit down and think of every scenario. What could possibly you say to the environment? Open the light, close the curtains, or hey Alexa, play me some music, etc. But these systems allows us to go beyond of that. You don't have to pre-code anything. It understands your intent by just talking with the environment. And another good example of usage is ChatGPT is activity classification. This time, I explained this lots of components to train the model, pre-process it, some expertise. ChatGPT allows to get rid of all of them. You just put raw sensory data to GPT and it actually manages to do activity recognition. There is no expertise needed for that. You just collect data, give to the large language model, and it can do activity recognition. Another good LLM example is Meta AI's large language model called Llama. This is powerful family of autoregressive language models for provide efficient high-quality language understanding. It is also employed for converting natural language commands into actions. In this work, the resident says, "Help me get better sleep," and then system understands this intent and arranges environment, arranges lights to home, arranges the home for the user. Another LLM example is bidirectional encoder representation from transformers and Gemini. This is the Google side of LLM base. BERT is introduced in 2018 and the Gemini is introduced 2024. BERT has a unique feature amongst LLMs. It has bidirectional encoder. Traditional transformer network predicts the next word of the sentence, looking back of the sentence. However, this bidirectional encoder looking back and forth, so it understands more content of the word. So it has unique feature. BERT is utilized for detecting behavior changes in smart spaces. In this work, it managed to get abnormal behaviors of the elderlies. This is again important work for living alone elderlies. And the Gemini used for HVAC control for energy management. Researchers gave sensor data to Gemini, and the Gemini controlled air conditioning on the real environment, and it actually managed to do energy efficiency in this environment. We have three important challenges utilizing of AI. First one is energy consumption, and second one is computational burden. These two somehow related to each other. Deploying these models are costly in energy side, and especially in large language model side. And also there is a privacy and data security concerns. When you talk with the large language model, it starts talking back to you by your saying, repeating what you're saying. So there is a privacy issue in LLMs. Okay, now finally introduced is done. We are here, the core of this talk, AI agents in smart spaces. AI agents compute resources available in the space. What I mean resources, I mean sensor devices, all the collected data, all the connections, according to the user preferences, and predicts user behavior to proactively offer services. Up until this point, even current smart spaces think space is like static environments, like it doesn't change. However, it's not real. Real environments are dynamic ones. So they have to adapt the changing of the environment. That's why we need AI-driven smart spaces. The feature of AI-driven smart spaces are natural language processing by voice commands and predictive personalization. Basically, there is a home AI agent, and you can talk your intent with it, and it actually arranges environments based on your needs. And it always tries to learn from you and provide you user-centric solutions. We can think of applications like predictive healthcare, adaptive environments, and advanced analytics. I can give one example for predictive healthcare. This AI agent can monitor your health data from your smartwatch or smartphone, and it can give you some suggestions and recommendations to improve your health. It allows you to monitor your own health. I would want that. And the challenges are again high computational demand and privacy concerns. Okay, what if AI agents decides to go breaking bad in smart spaces? Lots of things can go wrong. First one is malicious exploits. Some intruder can convince your AI agents to unlock doors or open and close some electronic devices to harm your home environment. And second one is breaches of personal data. Some hacker can get in your local network to convince your AI agents to share personal data, your credentials with them. And third one is loss of human oversight. With AI-driven systems, we don't intervene in the system. There is no human intervention. It does everything automated by itself. So in the future scenario, there might be conflicts. For example, I would like to increase temperature. It would like to decrease temperature for energy savings. There might be some conflicts in the future. And fourth and final ones are biases in decision making and ethical concern. Large language models are trained on internet data, websites like Wikipedia and Reddit. These websites are written by people, so there might be evil people or malicious people writing them, since they inherently have biases in their training. So it causes ethical concerns. Here's an example of bias in decision making and ethical concerns. In this example, the large language model we want large language model to complete given sentences. First sentence is the white man worked as a, and we want LLM to complete it 5 times. And we see jobs like white man worked as a mannequin, bus conductor, journalist. And when we prompt large language models, again with the black man worked as a, and we want LLM to complete, we see jobs like a car salesman, man-eating monster, and as a slave. As we clearly see, large language models have toxicity, discrimination, and exclusion for a group of people. And they have factual errors, misinformation, disinformation, and privacy violations. Okay, now in this part of the talk, I will present my own work, part of my thesis, a prototype of local running AI agent. The system, I intended to do that my own home AI agent that I can speak and control my home. The system continues to listen for speech input using a microphone, and then it uses speech recognition library in Python to convert spoken input into text. Then this text is given to GPT-2 language model from Hugging Faces Transformers library. Then the output again, text output, converts into speech using PyTT X3 library. Eventually, this local running AI agent allows you to speak with it. I utilize Bosch breakout sensor to measure air quality, temperature, and humidity. These real-time collections are given to the large language model with this RAG technique. Allows it to understand current conditions of the home. And in the future work, I will try to fine-tune this GPT-2 model with environment values so that it can produce meaningful outputs, so that when we ask the system, what's the temperature or what's the air quality here, and it should respond to us of the current situations. And also I would like to explore this evil side of these AI agents, what can go wrong. Yes, that's pretty much it. Thank you so much. Any questions?